Hello and welcome to my science tutorials. In today's video, we want to look at change of subject of relations. So without further ado, let's begin. Now, as a physics student or a mathematics student, one of the basic knowledge that you need to have, or one of the basic skills that you need to have in mathematics or in physics to help facilitate your study of the course is change of subject, because you'll be dealing a lot with problems and statements where you need to know how to maneuver your way to make a particular let me say a particular number or a particular item the subject, or a particular quantity the subject of a relation. So in this video we want to focus on that. We want to see how we can maneuver our ways to make a particular quantity the subject of relation. Now we are going to focus on some basic ways of doing that. So let's have a look at an example in this case. So let's say we have the relation. Okay, this is the relation given to us. So they said final velocity v is equal to initial velocity u plus acceleration and then time. Okay, so v is equal to u plus at. This is a very popular relation in physics. Now we need to know how to be able to make any of the parameters or any of the variables over here the subject. For instance, we need to know how to make u, that is the initial velocity the subject. So we should know how to make initial velocity the subject, how to make a, which is acceleration, the subject. We should be able to do that. And then t, which is the time, we should be able to do that as well. So let's look at that in this particular case. So the first one we want to do is to make u, the initial velocity, the subject of this relation. So we have v is equal to u plus at. Now to make u the subject, this is fairly easy and very simple. We can see that we have the left side of the equation and then the right side of the equation. Now the right side of the equation has u plus at. A and t are multiplying each other, so they go in pair. So in order for us to make u the subject, all we have to do is to maintain the u there and then send the at to the other side of the equal to sign. Now remember, if we move a number or a quantity across an equal to sign, the sign changes. So when it is positive there, it becomes negative. When it is negative there, it becomes positive. In this case, the sign before the at is positive. So when we move the at over the equal to sign to where the v is, it becomes negative. So we have here v minus at is equal to u. That is if we move the at to the other side of the equal to sign. So if we rewrite this expression by making u to be on the left side, we will have u is equal to v minus at, and this becomes the expression that we get when we make u the subject. All right, so let's look at the second one. Let's make a, acceleration, the subject. So this is I. Let's look at I. Let's make acceleration the subject. So we have u, v is equal to u plus at. Now if we look at this, like I said in the first instance, acceleration and time are multiplying each other, so we maintain them. So the first thing we do over here is to allow the variable or the quantity we want to find or make the subject to stand alone. That is our goal. So the first thing we need to do is that we have u, initial velocity, disturbing the acceleration and time, so we need to move it away. So we move it to the other side of the equal to sign. Because over here it is positive, when we move it, it becomes negative. So I have my final velocity, then I send the u to the other side, it becomes minus u, then this is equal to acceleration multiplied by time, at. Now that I have moved the u, I now have at standing alone, but I don't want at, I want just a. So to get rid of the a, to get rid of the t or the time, I divide both sides by time, and the time nullifies the time at the top over here. So I have v minus u over t is equal to a, which therefore means that my acceleration is equal to final velocity minus initial velocity on time. So this is the expression that I get after I make acceleration the subject. Right, so let's have a look at the last one. So let's make t the subject. So let's make t or time the subject. Now I still maintain the expression u plus at. Okay, just like the way we did for acceleration, we do the exact same thing in this case because we want to make time the subject. So over here, we first of all move the initial velocity over to the left hand side. So we have v minus u is equal to at. Now because in this case we want time and not acceleration, we divide both sides by acceleration and acceleration. The acceleration cancel. Then we now have v minus u over a is equal to time. So this expression is what we get when we make time the subject, and this is what we get when we make acceleration the subject, and this is what we get when we make initial velocity the subject of this particular relation. Right, so let's have a look at a proper example. So we are to make L the subject of the relation capital T is equal to 2 pi multiplied by the root of g on L. Okay, so let's have a look at the solution to this problem. Solution. Now, the expression we are given is capital T is equal to 2 pi multiplied by the root of g on L. Now, if we look at this expression very well, we realize that we have 2 pi multiplying the root of g on L, and then what we want to make the subject, the L, is under the root sign but still multiplying another quantity together. So the first thing we need to do is to first of all try and do something about the 2 pi that is over there, and then later on we get rid of the root sign. So what I will do over here is that first of all I want to get rid of the 2 pi over here so that I know the root of g on L stands alone and I can find the L separately. So the first thing I will do is to divide both sides by 2 pi just to get rid of the 2 pi. So I have t is equal to 2 pi the root of g on L. So I divide both sides by 2 pi. This cancels this, so it means I now have t on 2 pi is equal to the root of g on L. Okay, so now that I have this, the next thing I need to do is to get rid of the root sign over here, because without getting rid of it I will not be able to make the L the subject. So to do that, I need to square both sides of the equation. So I square this side of the equation, and then I square the other side of the equation as well. If I do that, the square root and then the square will cancel each other out. So I'll be left with t squared over here. So this will become t squared over the 2 pi squared. So 2 squared will give me 4, pi squared will give me pi squared over here, and this is equal to the square sign over here cancel the root sign, so I have g on L over here. So from here The next thing I can do is that I can cross multiply to have my equation in a linear way. So it means I will multiply the t square with the bottom one over here, the L over here, and then I'll multiply the g with the 4 pi square over here. So that basically means I'll do this, I'll do this, multiply this, multiply this. Okay, so if I do that, I'll have L t squared is equal to 4 pi squared multiplied by g. Okay, now that I have this expression, let me rewrite that. LT squared is equal to 4 pi squared g. So now that I have this expression, I need to make sure that the L that I want is make the subject. So to do that, I divide both sides by t squared and t squared. So t squared will get rid of the t squared here, and then I will be left with L, which is now the subject, to be equal to 4 pi squared g over t squared. And this becomes the expression that I obtain if I make L the subject for this particular expression. All right, so let's have a look at another common example that we normally find in physics. So let's have a look at this particular expression. So we have 1 over r total is equal to 1 over r1 plus 1 over r2. So we are to make rt or r total the subject. Okay, so this is a formula that we use when we have resistors in parallel in physics or in circuit equations or circuit problems. All right, so let's make r total the subject. Now for us to do that, let's write down our solution. So in doing that, we write our expression first. So we have 1 over r total is equal to 1 over r1 plus 1 over r2 over here. Now there are so many ways you can do this, but the easiest way, or the way I go by this, is to first of all I look at the other side or the right hand side of my equation. I realize that I have fraction added by another fraction. So 1 over r1 is a fraction plus 1 over r2 is also a fraction. So I need to find LCM for both 1 over r1 plus 1 over r2, and then the LCM will just be the multiplication of r1 and r2. So it is r1 r2. So I still have my 1 over rt over here to be equal to, now 1 over r1 plus 1 over r2, their LCM is r1 r2. Now r1 will go into r1 r2 r2. Let me take that again. It means that r1 will cancel r1 over here, and then we'll be left with r2. That r2 multiplied by 1 will give us r2 at the top. Then we bring the plus sign. Then the r2 over here will cancel the r2 at the bottom. We are left with r1. So we have r1 multiplied by 1 at the top here becomes r1. So from here, let me rewrite this. I have 1 over r total is equal to r2 plus r1 on r1 r2. So from here I can cross multiply. So I cross multiply so that I have my equation in a linear form. Now I have r total will multiply r1 plus r2. So I'll write it like this: r total multiplied by r2 plus r1, so that I don't expand the bracket and later on have to factorize again. So this is equal to 1 multiplied by r1 r2. So I have 1 r1 r2. So I maintain here r total into bracket r2 plus r1 is equal to 1 multiplied by r1 r2 will give me r1 r2. So now I know that I want my r total to be the subject, so I divide both sides by R2 plus R1. Here R2 plus R1. So this will cancel this. So therefore my R total is now equal to R1 R2 over R2 plus R1. So this becomes my expression after making R total the subject. Now note that along the calculation, for people who are a little bit advanced in mathematics, from here all the way here, all we need to do to get R total is to flip the equation. So we bring R total over here, then we bring the 1 to the bottom, and then we do the exact same thing over here, and then we'll get our answer. Let's look at that. If we interchange the position over here, we'll have R total on 1 to be equal to, then we send the R1 R2 to the top, we'll have R1 R2 on, then we bring R2 plus R1 to the bottom, we have R2 plus R1. Okay, now R total divided by 1, any number divided by 1 is the same number. So here will give us R total, or RT, is equal to R1 R2 over R2 plus R1. Okay, so people who are advanced in mathematics can just swap the position over here and get this answer straight. But if you are not good like that, or you are not sure, go through the normal way of making R total the subject, and then you have your answer. At the end of the day, they are all going to be the same, or they are all going to be correct. So the end goal here is to have the answer correct, not to try to show that you are advanced in mathematics or physics and get your answer wrong. So this is how we make a particular quantity the subject of a relation. So thank you so much for watching, and I'll see you in the next video. Bye bye.